Now let's take this question which appear very interesting. It says that there is a square ABCD which has a dimension of 12 centimeter, and there are 2 points E and F which are the midpoint of AD and BC. So this is the point E and this is point F, which are the midpoint of AD and BC. Further, it says that AC, BD, CE and DF intersect the interiors of the square to form a quadrilateral PQRS. So all these points, like the point AC is joined, which is nothing but the diagonal of the squares. Same with BD, and these midpoints are joined with the opposite endpoints. So it is EC is joined and DF is joined. So these are the intersecting points, that is P, Q, R and S, and we have been asked to find the area of quadrilateral which is in the shaded regions. If we apply only plane geometry concepts, it might take a lot of time and effort to get the answer, because the required area is awkwardly positioned inside the square. So since it's a square and the dimension is also given, I'll be using coordinate geometry and will take the help of plane geometry wherever required to get the answer as soon as possible. So let's start with this point D. So let me assume that this is the origin. So quickly I can plot all these points. So this will be 0, 12. This point will be 12, 12. This point is 12, 0. Since E is the midpoint of AD, so it will be 0, 6. Similarly, F would be 12, 6. And since P is the midpoint of BD, so its coordinate will be 6, 6. Similarly, the point R is the midpoint of DF, so it's easy to find the coordinate of the same. It will be 12 plus 0 by 2, so this point will be 6, and it will be 6 plus 0 by 2, so the y coordinate is 3. So we have identified the coordinates of P and R quickly and easily. And if you look at the coordinates P and R, the x coordinates remain the same. The x coordinate of P is also 6, P is 6, and the x coordinate of R is also 6. So I can say that PR, if I join them with a line, then this will be parallel to y-axis, because the x component of both the coordinates or both the points are same, and the length of the PR is nothing but this length. The y coordinate of R is 3 and the y coordinate of P is 6, so the length of RP is 3. I have actually calculated one of the diagonal of the given quadrilateral. Now let's come down to finding the coordinate of point S, which can be done by various ways. We can make the equation of EC, because the 2 points are given, and we also know that this line DB is nothing but y is equal to x, because it is at 45 degree, and we know that the equation of line at 45 degree from the x-axis passing from the origin, y is equal to x. So but I'll try to use some plane geometry concepts. You observe that AD is parallel to BC, and EC and DB are intersecting. So it's something like which we already did in the concept which we studied in similar triangle, that if there are two parallel lines and if there is a cross going on, then the two triangles so formed will be similar triangle, because this angle will be equal to this angle will be equal to this vertically opposite angle. So these two triangles become similar. So I'll be using that concept. So we can say that triangle ESD is similar to triangle BSC. I hope you can locate this. So the base of both the triangle, or this ED, is the corresponding side, or the corresponding sides. If ED is the one side of the triangle ESD, then the corresponding side will be BC. Now the length of this is 6 and the length of BC is 12. So I can say that the linear dimension of both these triangles will be in the ratio of 1:2 because they are in the ratio 6:12. Now let me draw a parallel line to DC passing through S. If I draw this, it's very sure that it will pass through both S and Q. Say this point is T and this point is U. We can say that if ED is the base of this triangle, then TS is the height. Similarly, if BC is the base of the other triangle, then US is the height. And these heights should also follow the same ratio, that is, they should be in the ratio 1:2. Now what is TU? TU is equal to DC, which is equal to 12 centimeter. So I can say that TS should be 1/3 of TU, which is 1/3 of 12, which is 4 centimeter. So I can say that the x coordinate of point S is 4. And it's easy to find the y coordinate also, because ds is y is equal to x. The equation of ds, as we have already seen, is y is equal to x. So whatever will be the x coordinate, the y coordinate will also be the same. So we have identified the coordinate of S. With the similar logic and symmetry, I can say if S is 4 centimeter away from this line, the point Q will also be 4 centimeter away from this line. So this coordinate should be 8 and 4. Now you can see that we have identified the coordinates of all the 4 coordinates of the quadrilateral PQRS. Now one of the diagonal is PR, which is of 3 centimeter, and the other diagonal, we can observe that now here the y coordinate of P and S are same, hence SQ is already parallel to DC. So the length of this value SQ, the length of SQ will be 4 centimeter, and both PR and SQ will be perpendicular. So we already identified that PR is 3 centimeters. Once we have identified this and the relation that PR is perpendicular to SQ, now we can easily find the area of this quadrilateral. We know that for any quadrilateral, area of quadrilateral is equal to 1/2 the product of their diagonal and sine of the angle between the diagonal. Now since the angle is 90 degree, we know that sine of 90 is 1, so this component goes out. So for the area of quadrilateral PQRS, it will be half of PR into SQ, which is 1/2 into 3 into 4, or equal to 6 centimeter square.